Okay. Sorry for the interruption there, and I'm getting everything set back up. My computer completely crashed while trying to export from Darktable there. So we've got the JPEG, so we'll just have a look at that. That's okay. Let me get the music back going. Sorry for the interruption. Okay. Oops. Actually, this is not where I want to be. I want to be in here. Did we not get the JPEG either? Oh, they did. Okay, yeah, okay. Well, looks like we didn't get the JPEG either. So, you know what? We're just gonna open up and I guess we're just gonna look through what we exported from GIMP, because I'm not trying that again right now. I guess. I don't really want to try that again. I may not have much of a choice though. I don't know why the Windows photo viewer is not able to open that. Okay, well, photo viewer is, I guess, but the regular Photos app isn't. Alright, so right here, as I said before, is the trapezium cluster, which is 5 massive stars. Looks like there's another one right here, actually. And all of these right here, especially this, that is a baby star. So that is a star that is still forming. And these are just blowing off material that is trying to collect around those stars. So, you know, I'm no astrophysicist, but I would say that their size is actually going to be limited due to these stars. By the way, while these stars appear many, many pixels in size here, just like always, like these little stars are at about the same distance. It's just because these are so bright. They're not this large in comparison to these. They're just really, really, really bright. Let's see what other kinds of interesting things we could see. So obviously there's another kind of, you know, tadpole looking thing. Right here. See this right here? That bow shock? That is a star that was just born and is now pushing away material. So that's the solar wind from these stars. See that right there? Again, I'm no astrophysicist, but if I was to guess, that actually is a planetary disk. So that is the disk of dust and gas surrounding the star that is going to eventually coalesce into planets and then get blown away by the star. Let's see what else is interesting that we can find in here. I think there's a star right here that is like kind of behind some of this dark gas. By the way, what this is that there's another star right here that, just like these, has blown out part of the nebula. And if you kind of let your mind wander just a little bit, you can see that this actually is a spherical shape, and this is just a piece of gas and dust that is in front of that. So this is like a ball, and this is the back side of it here. So just like this side is blown out, so is this right here, and it's hollowed out. You can see that down through here by, again, just probably mostly this one, but some stars back in here. And this is in front of this. Probably significantly closer, but I don't know that for sure. I think these are probably red dwarfs, or new stars maybe. Excuse me again. This right here is another instance of the star hollowing out a section of the nebula where it's born. Right there is a huge bow shock from this star. So this is obviously inside the nebula. Some of these stars are probably, like this one probably is not in the nebula, it's probably in front of it, closer to us. But this one is obviously inside the nebula and is just, its solar wind is just making this huge bow shock. So all of this gas and dust and everything that's getting blown out by these massive stars here, well, this one's solar wind is pushing back almost as hard. Right there's another, there's probably a little baby star in there, a protoplanetary disk. I bet. I'm not sure what's going on here. I'm not going to try to speculate on that. What's this crazy line? What is that? That's probably just some optical artifact. Internal reflections somewhere. It's kind of cool. It looks to me like this star is also clearing out a portion of the nebula, but this is a little more diffuse. And this is probably bright like this and not red because it's reflecting off of this. Most of the light coming from the nebula is made up from these stars here and these three stars right here, but mostly this cluster right here. You can tell that this star is embedded in the nebula. because of the way that the gas is reacting around it. And you can see that this wall right here is, you know, just like this was up here, this kind of bubble that is pushed out. That's what this has done here, just hollowed all this out. And so this is probably kind of shaped like a kind of little W right here. And then you've got this wall that curls up. So it curls under. Let's take a look at this. Yeah, it looks like it curls under, goes up and over, back down, and then it curls back up right here, and then back down. Keeps going. This is in front of it. It's a little wisp that's in front of it, I think. And then it curls back up over here. Now, this wall here, so this, I think, is partially reflecting off of the star. When you look at this portion of the nebula through a telescope with your eye through a telescope, you can see this wall. So, and you can see these dark parts right here. This is like extending over this part of the nebula, but you can see this in a telescope as well, and you can start to see some detail in it as well. You can also see, and I'm talking about, I'm using my 8-inch Dobsonian, you can also see this like arm of gas. You can see that. It looks like this is kind of hollowed out more than this part. If you look really carefully, you can also see, you know, little bits of this. Though I'll be honest with you, and they're probably just too faint to see. I don't know that I've ever seen any of these smaller stars in this cluster. But I've seen all of these bright stars. Looks like a baby star right there. Little bow shot going on here, I think. I think this is an optical aberration. I don't think this is real. That is kind of similar to, I just did this one. That's kind of similar to this, I think. And that's not real. That's some kind of weird internal reflection or aberration on the mirror. Mirrors. There's more than one mirror. Anyway. So I don't think that this is actually real, but I could be wrong. That could be an actual feature. What's going on here? Looks like another protoplanetary disk, and it's kind of pointing, yeah. So it's going to be slightly behind these in reference to us, because its tail is pointing this way and it's hard to see. So I suspect that this is pointing this way and back away from us. I bet these stars right here, these are probably actually a double star system. Oh, got some, these might be, I feel like these are likely to be jets coming off of that star as it's being born. So a little bit of gas there. I wonder if these are stars or will be stars. Maybe a little hint of a bow shock right there. There's another one of these. I don't know. I don't know about that. These are hot and cold, hot pixels. So that's basically dead pixels in the sensor of Hubble. So right here you can see there's like a line of them. That's going to be where the seam is, where they've stitched the mosaic together. One of the seams. You could probably find a lot of those if you really looked around. Look at that. That's definitely a star that's like embedded in all of this dust. These are hot pixels. I wonder what is behind this. I wonder if this star is behind all of this, and maybe it's actually really bright and only a little bit of its red light is getting through the dust. I think kind of same here. I think there might be some stars that are hollowing that out behind it. Alright, there's another baby star right there. I lost it. Yeah, I lost it. One too many scrolls on my mouse because I was being impatient. Sorry about that. Ah, there it is, right here. So that is a baby star that has enough solar wind going on to kind of blast out material. And you can see that it points directly back to some of these huge stars. So there's like a current almost. Look at this. Look how that's hollowed that out. Isn't that crazy? So this star is slightly closer to us than most of the rest of the nebula that's behind it. And you can just see how it's hollowed that out. I bet this little like chunk of gas kind of just hovers over top of it. So you would see that if you were on a planet near it, I bet. Oh, what's this? I bet that's a bright star, actually, but it's behind all this gas. That looks like a reflection off of some of these red stars. By the way, you may be wondering if I am capable of imaging some of these really small details, and the answer is no. I don't think my telescope, even if I put in hundreds of hours, I don't think that I would be able to resolve a lot of. Maybe I should try though. Maybe I should push my telescope to its limit and see what we can do. So maybe once I get that mount working again, that'll be next year, because the Orion Nebula is already kind of out of reach for me. It's behind some trees by the time it gets dark now. Kind of a hollowed out area right here. See, that's the thing with Hubble's images of especially this nebula is you can, especially if you zoom in, like out here, I don't know, it doesn't mean a whole lot, but when you zoom in, it's like, it's three-dimensional. Like, you get a lot more you just get a lot better idea of exactly what you're looking at, I guess is what I'm trying to say. Look at this. Look how detailed this little wisp, which is, when I say wisp, I say little, but this is probably thousands. I mean, well, it's going to be several light years anyway. It's not going to be thousands because the whole nebula is only about 1,500 light years away from us, if I remember correctly. Look at that. Kind of wrapped in gas. Anyway, if I remember right, the whole nebula is only about 1,500 light years only. And I forget exactly. So it is 13,500 light years. And what I want to know, let's see. Okay, so just this cluster right here. This is 1.5 light years, just this part. So what part was I even looking at a minute ago? Anyway, that kind of arm of gas that I was looking at is probably a good 20 light years. Or, maybe I'm overestimating it, but it's some insane distance anyway. If you're looking at this, the distance, just to give you an idea of how close together these stars are, if this is 1.5 light years, and say the sun was right here, that would put Proxima Centauri, our closest star, which is 4.5 light years away, probably somewhere over here. So, and there's nothing in between that where we live. So if you can just imagine how close these have to be together, it's absolutely insane. Here we go. This is the piece I was looking at. So this whole piece right here, if I compare that to this, and I'm just kind of eyeballing it, that's probably 3 or 4 light years. So this is the distance right here between us and our closest star. And right here, there's like, within that is probably, I don't know, 100 stars. Just right here, in this area, right here. There's probably 100 stars in there. But anyway, we'll zoom out, have one more good look. Let's zoom in so that it fills up my screen. I'm just going to take it down. See if there's anything. What's this? That's one of those optical aberrations. You know what I would like to see is some like really clearly defined jets. It's kind of oblong. I wonder if that's some jets. Because when baby stars are born, they just emit massive amounts of radiation from their poles. I wonder if this is actually coming from that star. Oh goodness, it's about time to wrap it up. Oh, that right there, you see that? There's a bow shock there, and I think this is a jet. I think there's a star right here, and I think these are jets coming off of that star. See how that's kind of oblong? Oh. I mean, you could legitimately dig around this for hours. And honestly, I don't know if it's just because I'm more used to looking at images in this color palette or what, but this makes more sense to my eyes than does the that's cool, than the color palette that the Hubble team uses. Again, there's nothing wrong with what they use. This looks okay. You see how this doesn't have diffraction spikes? There's no spikes on it. That means that its light is getting scattered, which means that that star is probably incredibly bright and is still shining through some of this gas. Now, if you can imagine, this is like a shelf behind or in front of all of this, so there is untold amounts of things to look at that we'll never see behind all of this. All right. I think I'm going to call it a night. Give it one more look down here. I don't think we've looked much down in this area. That's probably a double star right there. The dark parts of the image don't get a lot of love, but I bet there's probably some interesting stuff in here to someone. What's up with that? See that? That's kind of weird. All right. Yeah, alright, I think that's it. Alright, so if you enjoyed the stream, whether you're watching it now or later, is there any, there's somebody in here right now. So if you're watching this later, I hope you enjoyed it, and if you can give me a comment, whether you liked it or not, just any, helpful suggestions, I'd love to hear it. And thank you for watching. If you watched any of this, have a good night, or morning, or day, whatever time you're watching this.